Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we have an episode of PC Archeology, but unlike the usual ones where I look at an entire PC, we're only going to be looking at one card. And it's this card here, which was found by my friend Mike in an old IBM PC 5150. I saw this card when I was over at his house poking around those computers, and I thought, this is really fascinating for a couple of reasons, really. One of them was that, well, I'd never heard of this card. It's made by a company called Destek. But second is this thing has a Z80 processor on it. That's kind of unusual for something that's an ISA card in an old PC 5150. But even more odd is the computer was totally diskless. It only had this card installed and a monochrome video adapter, and that's it. No floppy drives, no hard drive, nothing else. So I was super curious as to what this machine, well, it's actually three of them that had this card and were configured the same way. What was this thing used for? Was this some type of network interface card or serial card allowing you to connect to a mainframe or some networked system? So in this video, what I want to do is take a look at this card, see if we can see what's going on with it, dump the ROM, try to do some searching to figure out if there's anything from this Destek company, and then maybe try this thing out in a piece of hardware and see what it actually does. So without further ado, let's get right to it. So what's funny about this card is when I was over at Mike's house, he actually had these three computers that he was trying to give me. And these 5150s were all super rusty because they were from a big rescue that he did a while back. And I was like, I already got 5150s. I don't need any more. But I wanted to look inside of them because I thought the whole diskless situation was really odd. And that's when I opened it up and saw this card. And I thought, oh, well, I'm going to pop this out and maybe make an interesting episode of PC Archeology, which is exactly where we are here. Now, pretty typical for me, I'm starting this episode not having done any research on this card whatsoever. I haven't done any Googling, I haven't tested this in a computer, I haven't turned it on, I haven't done anything. So I'm thinking right now on what exactly I should do here. I think the first thing I'm going to do is plug this into a computer and let's just see if this actually does anything plugged into a computer, because that's seemingly how it was used in these 5150s. Without a disk drive or hard drives, I don't see how you could run any software on these machines because they'll just boot to BASIC without a disk drive or hard drive, and you can't really do much in IBM BASIC. You can't start executing code off of a card like this. I don't think you can, at least. So, okay, let's give that a try. All right, so on the bench, I have prepared an IBM PC XT clone, of course, to plug this into. It's got 640K of RAM. The original machine that this card came out of, I think, had 256K on board. It was the later version of the 5150 that could have 64K and could have up to 256 if you had all banks populated. The 5150 also had an MDA card. It was an IBM MDA card and simply had this card installed, and that was it. So it didn't have any other cards other than the MDA and printer port card. No floppy controller, no hard drive controllers, nothing. Now this particular computer has this 286 accelerator plugged into it. Hopefully that doesn't cause us any issues. I figured I should run this on an XT at least for bus speeds and things like that. So hopefully this is a good enough example. So let's just plug this card into the motherboard. We'll just stick it in this random middle slot. And I have the video card plugged into the RGB to HDMI, and I have an XT keyboard plugged in. Let's turn this on. The computer is powering up. That's a good sign. So is this going to do anything? No bootable disk. So that means this thing's just going to jump into BASIC. Well, this is odd because I don't really understand how this card could have been used if it doesn't seem to do anything, like it's not presenting itself as a ROM BIOS. My only thought is the 5150 with this card in there and you powered it on would drop to BASIC just like we had happen here, and then you did some, I don't know, did some commands to jump to an instruction. I'm not even sure if you can do that. Can you jump to ROM code in BASIC, IBM PC BASIC that is, and run something? Let's take this card out and we just need to take a closer look at it. So here's our card, and it's a Destek card from 1982. A few observations about this card is take a look at the way the traces are. I have a feeling this was probably laid out by hand on a large format piece of paper, and then they shrunk it down to create this PCB. Backside of the board, well, very similar with all these curvy and natural looking traces. There is some flux right there. That is for the dip switches. And then we have a little bit of flux over there, and that is an IC that I assume was reworked. Now I grabbed some high-res pictures of this so we don't have to work off the camera, so we can like really zoom in on this. So let's take a closer look at all the constituent parts of what make up this card. Now first I have to say that anytime I see cards that have these traces that are flowing like this, it really kind of blows my mind that this stuff was all done on pen and paper, or they probably use little stencils to draw the traces. But this curviness comes from the fact that someone was routing all the signals just using, well, by hand, and then it was all shrunk down and turned into a PCB. So let's start in the bottom left corner. There is the CPU I talked about. This actually has a Z80 CPU on it, which is quite surprising. When I took it out of the computer, I was like, wait, what is this? I don't understand. And how could this be in a diskless system? As I mentioned, there were 3 identical machines, all diskless and all with this card in there. Next to the CPU in U37, there's a component that unfortunately is really difficult to read, and it's not just because of the photograph. It was very hard to read on the physical card. So it turns out that that part is an Intel 8237A-4. which according to the datasheet is a high-performance programmable DMA controller. I would have thought this was some kind of like parallel I/O type controller, but apparently not. Moving over to the right, we have a couple latches. These are LS373s, or yep, at least one of them, no, 2 of them. And then we have 2 Toshiba static RAM ICs. Pretty sure these are going to be 2K each, 2K by 8 bits each. I can never quite remember exactly the size of these, but yes, indeed, that's the same as the 6116, and it's 2K by 8. Same SRAM that's used on, say, the Commodore 1541. So we have 2 of those for a total of 4 kilobytes of RAM. Next up, there's an EPROM, and it's labeled MON100, and this happens to be a 2732, because I already dumped this. And a 2732 is 4 kilobytes in size as well. Now, since this didn't do anything on the PC, it wasn't a PC BIOS type ROM when it was plugged into an ISA slot, I'm assuming this is for the Z80, so it helps the Z80 execute whatever code it does. And a Z80 begins executing its code from address 0. So typically you have to have the EPROM or the ROM mapped at the very beginning of address space. This is different than the Intel 8088, 8086, or really any x86 processor, and the 6502 and the 6800 from Motorola. Those all start executing from the very top of memory space. And what happens when you first turn on like a 6502 machine is it goes to the very top of address space, or nearly the very top. And in there's a few bytes that are going to be used as a jump vector. So that tells the program counter where to start executing from. So any 6502 based system always has to have its ROMs mapped to the very top of address space, because that's the first thing that the processor does when you first turn on the computer. But on a Z80, this should be mapped into the beginning of space. Now, what's very common for a lot of Z80 systems that, say, have 64K of RAM, they start executing code from the ROM, and then very early on, it might copy the ROM code into RAM, and then it actually disables the ROM. So there's some bank switching type circuitry on the board that turns off the ROMs and activates RAM in that lower chunk of memory, and that gives you a full continuous 64K of RAM. Okay, moving on, we have U44, and this is a Z80 ACTC, which I think off the top of my head is a timer chip. And I think this is it right here. So is a Z80A, like Z80A is the processor, and then CTC, counter timer circuit. 4 independently programmable counter timer channels, each with a readable down counter and selectable prescalers, blah, blah, blah. Yeah, I think generally these are used on Z80 systems as a timer functionality. This is very similar to like the beep speaker on the IBM PC. It uses an Intel version of this chip to generate various timers to do all sorts of system housekeeping things, but also generate the beep speaker. Continuing on, obviously there's a bunch of 74LS logic we're not looking at. We have some dip switches. Everything is on except for 5 and 9. Maybe this sets up an I/O address that this card can respond to or talk with on the ISA bus. Clearly, this stuff is connected to the ISA bus, and we also have these jumper links. Maybe this also configures certain addresses or something for this card to respond on. If we imagine on P2, the top pin is 1, which kind of coincides with the tops of these ICs. Then 1 is connected to 8, and 2 is connected to 7. I'm just taking some documentation just in case anyone ever gets one of these cards and they want to set theirs up in a similar fashion. U36 is a PAL. It's probably programmed to do some type of chip select logic, something like that from the ISA bus, just by the fact that it's really close to the ISA bus. Looks like we have some flip-flops or latches, and we also have a bus transceiver, and then some 74LS logic. Now, moving up, starting on the top right corner, we have what looks like the Western Digital 19338-03. I think that's an 8 or a B. Could be a B. Can I get a little closer? That's probably a B. So quick look on Google. Someone is selling one for 10 bucks. Here we go. Here's the data sheet. Synchronous data link controller. HDLC, SDLC, ADCCP, and CCITT X25 compatible. That's a lot of acronyms. Loop data link capability, full and half duplex, up to 1.5 megabits per second, different encode decode schemes, digital phase lock loop, minimum CPU overhead, asynchronous and synchronous multi-protocol board capability, pin compatible with a Western Digital 1931, fully TTL compatible, DMA compatibility, variable character lengths up to 8 bits, applications, computer communications, terminal communications, and computer to modem interfacing. Now, I don't think this is going to be used with a regular modem that you're thinking of, because this is not RS-232. These are these synchronous type connections. And the fact is, it's 1.5 megabits makes me think that maybe this has something to do with a T1 or some type of telecom line like that. And CCITT X25 kind of reminds me of the whole T1 thing. Packet switch data communications, wide area networks. Comes from the Orange Book in 1976. Okay, so maybe it's not T1 specifically, but it is some type of packet switched network, X25, with data carrier equipment, and a bunch of things talking through a private cloud. And this is like late 70s, early 80s stuff. I've only heard about these types of networks before. One of my first jobs, we actually had some leased lines with synchronous modems connecting two buildings together, and it was a slow link, but fast enough for terminals to go across. I remember that it was very costly, and we got rid of it pretty quickly simply because it just wasn't cost effective, and I don't remember what we even moved to. It looks like this X25 network, at least according to Wikipedia here, could be billed as a flat monthly rate fee depending on link speed, and then price per segment on top of this. Link speeds varied from 2400 bits per second all the way to 2 megabits, although speeds above 64 kilobits were uncommon. Calls invoking the fast select facility, allowing 128 bytes of data in call requests, call confirmation, and call clearing phases would generally attract an extra charge. And you know, there's a bunch of stuff here. This is all like pre-internet stuff. Well, I mean, maybe the internet did traverse some of these types of networks, but ultimately businesses were using this as well, and whoever was using these 5150s. And HDLC, which was mentioned in the datasheet for the chip, was the high-level data link control, and it's based on the SDLC, which is synchronous data link control. These are all framing standards for the transport of data, and you can see that the dates are pretty old on these, but obviously that's what this chip specializes in. And this card would have been connected to some kind of modem. It has a 15-pin connector here, DB15. I didn't really get a good picture of it, but this is connected up to this Western Digital IC for transferring this data in a synchronous fashion. All right, back to the card. We have another PAL doing something. It's obviously is connected to the Western Digital IC. There's another PAL in U30, some more TTL logic. Looks like I have another switch block. I didn't even notice that. Let's look at how those are set on the actual card. Looks like switch 1 is off and switch 2 is on. That's on this little switch 2 block. Some more TTL logic up at the top here. Another PAL. So this is all obfuscating logic away from us, so we don't really know exactly what those are doing. Some blanks which aren't populated. And finally, some more TTL logic. Although, what's this? S0081. I don't know what that is. And if we look at the back side of the card, just so you can see what we have here, just a lot of hand laid out traces. Some kind of ugly flexy rework there. That was the IC in the corner. Not sure what that logo is. A bodge wire. And there's that 15-pin connector that goes to the modem. There's a flux from the dip switches. And that's really it. There's no writing or anything on the back of the card. Now there is the presumable brand of this, Destek 1982, and that is written there. There's their logo, Destek Mon 100. Let's do a Google, see if I can find anything for that. Here's a Destek 85 spooler, so print spooler. Looks like it's the same company, 1985. I'm not sure if 82 on the card that I have here is actually a model number, or is that just a year? Photograph's pretty low resolution, so I can't quite make out the dates on these ICs. This one there looks like it's 1987. Now I'm just looking for other Destek S100 bus cars, but that seems to be the only one listed anywhere on the internet, at least that I can find. Oh, how about here on DeRamp? Oh, here's another picture on DeRamp of the spooler. I swear that says 83, although the picture is super low res, so it's hard to tell. It does say Destek 85 though, so maybe that is a model number. Looks like there was an NIB 1000. Oh yeah, there it is. I guess that's the model number. Okay, so Destek 82, that's what we need to look for. I'm just interjecting while editing. I didn't realize it while I was shooting the video looking at this card, but this is clearly the same card that we have in front of us. It's got a Z80, it has the same Western Digital chip on it, a ROM, that same Intel DMA controller. So this is the S100 version of the card we're dealing with here. The original me, while I'm making this video, found some more information that kind of confirms that there was an S100 version of the card that I have in front of me, the ISA version. So just keep that in mind as you keep watching. Over on DuckDuckGo, which is basically Bing, nothing about archive.org. Okay, well, no, I don't think this is that's what we're looking for either. I'm curious if we type in Destek 85, does that come up with anything? No, also not. Okay, I searched for Destek NIB 100. Bitsavers came up. Now, weird is, why doesn't it come up if I just type in Destek on its own? Oh, I see it. The results are polluted by this virtual reality stuff. Okay, so adding Bitsavers did bring up a little bit more info. Okay. Destek Group, DesNet. There's our address, East Evelyn Avenue, Sunnyvale, California, 94086, which almost surely it's someone's personal house now. So my assumption is this used to be something else because these look relatively new. And this was probably some type of a business park at some point in the past. And yeah, it's been turned into houses now. Anyhow, DesNet, baseband network using coaxial cables, CSMA/CA access method, and bus topology. Options include boards for broadband, fiber optic, telephone line communications via modems, 3 types of add-ins. NIBs are provided for IBM personal computers, multi-bus systems, which like Intel came up with that multi-bus, but Silicon Graphics ended up using that early on as well, and S100 bus-based systems. NES versions connect to dissimilar system peripherals through RS-232, parallel I/O, and either Centronics compatible port or IEEE 488 port. 2 megabits. NAS level networks can interconnect almost any combination of dissimilar processor peripheral devices. I mean, I really feel that this is something else. This is definitely not, I don't think, what we have here. Although maybe that is what this is actually. It does say that this was first announced first quarter of 1982. And over 100 with S100 multibus and IBM PCs are in individual or mixed network environments. Purchase price for the network interface board for baseband networks is 500 to 700, quantities of more than 2. Purchase price connector station is about 1,000 to 1,500 for fiber optic cable and 1,200 to 2,500 for broadband cable. This is all in 1982. Here's something else on Bitsavers that seems to have Destek as well. Same kind of thing, local area networking. On retrotechnology.com, we have some undocumented S100 bus boards, and it says Destek 1985 video board. I wonder if that's just miscategorized, and this is actually one of these network interface boards, which we saw exists. All right, look at this. User group news, Tektronix. I think this has the word Destek in it as well. Destek offers a real-time operating system kernel in C, 250-byte minimum microspecific code for $8,000 with rights for unlimited binary copies. There is support for hierarchical file systems, networking, and debugging. Destek will offer a C68000 compiler in November with vendor support for other micros follows. Call vendor reference blah blah blah. See vendor contacts. Let's see if this is the same Destek. Oh yeah, Destek. Here it is. Dennis Reiger, marketing manager, and it's the same address in Sunnyvale. So they were doing more than just hardware, making a real-time operating system that could compile on the 68,000, it sounds like. Neat. Okay, here's another document that has Destek in it. Is this a painting? Look at this. That's so funny. January, USA, 1982. Okay. And there it is, Destek Group, Advertisers Index, page 148. Okay. Well, let's go to 148. Yep, it's an advertisement for DesNet. It brings a whole new concept to local area network access with a low price. Interesting though is Destek Group has a different address here, 1923 Landings Drive in Mountain View, California. It does seem like it's the same company, although is that logo? Well, that logo is not exactly the same as what's on this. And I'm noticing, by the way, this says Destek 1982. I thought it said Destek 82. So that's got to be a year and not actually a product number. Well, searching for Destek, DesNet, ISA card, that's not bringing up anything. So it appears that these DesNet cards are kind of lost to time, or the search results are polluted by this virtual reality company. Now, incidentally, looking at this card, I didn't talk about this, but we have a serial number. Presumably this is the 58,000th card, 58,301. I assume the 100 is just a placeholder. And then we do have this assembly number here, 00750003-001D. So I've talked about this before a little bit, but it's really surprising when presumably there's like 58,000 of these ISA cards floating around out there, or they were floating around out there, or more. It's not like this is the last one they ever made. And yet we really can't find anything on this card ever existing. And this is quite an interesting card in that it has a dedicated Z80 processor with RAM and ROM and a bunch of support ICs, connects to the ISA bus and this Western Digital Synchronous network controller. And presumably this was to facilitate network communications and offload a lot of the heavy lifting from the CPU. So presumably the Z80 is running some code that talks to the other nodes and handles that gracefully and in the background, and probably generates an interrupt for the IBM PC to then receive a byte of data, or for sending data, same thing. And maybe these have addresses and the Z80 is what's handling all of that. It would definitely be a good way to go about this if you're talking about a 4.77 megahertz IBM PC, which just doesn't have a lot of horsepower, especially if you're going to be doing real-time communications and you want the machine to be able to respond very quickly. You need to use interrupts to do that. And of course, you're going to need to decode like nodes or address numbers, kind of like Ethernet MAC addresses in hardware, so that your computer doesn't have to sit there and look at all the traffic that's coming across the bus or whatever it's connected to and decode all of that to figure out what is actually meant for it versus meant for other computers on the network. So I did remove the ROM from the board and I dumped it. And this is the ROM. And looking at this, the first 4 bytes are actually some code, and then there's a bunch of Fs. And this really makes me think that this is going to be a Z80 ROM. Now, right off the bat, it goes to copyright 1984, Destek Group, MDN 100. Oh, I thought it said MON, but it's MDN. So I wonder if DN 100 is DesNet. And we saw something about network interfaces 100 mentioned in those Bitsavers article. So this has got to be one of those cards. And then it goes on to just have a bunch of code. Remember, this is 4 kilobytes, but there's not a whole lot. You can see that the majority of this EPROM is just empty. And you have to remember that a processor like the Z80, it doesn't need a lot of code to actually do something. You don't have to write an entire operating system for it. You can just low-level program the functionality you need it to do, and presumably that's what's going on here. So I decided to run this through a Z80 Disassembler, and here is that Z80 output. Now, I don't know Z80 assembly at all. I've never really worked in it. Now, it's similar to other period processors, very simplistic. But the only thing I did know for sure is that a Z80 always starts its execution from the beginning of address space, which is 0000. So I told the disassembler that that's exactly where this ROM was. And if we scroll down to the beginning of code, so there's the org statement with 0000, the very first thing is disable interrupts and a jump instruction. And that makes a lot of sense. So it's disabling the interrupts on the processor and it's jumping to 0514. Now create a label, label 2. So we can go to label 2 and oddly enough, it does another disable interrupts and then it does a bunch of stuff. So it loads 2000 into a register. does some stuff in the registers, it goes into a loop. I don't really know exactly what this is doing, but there are some various subroutines, things like that. It could be clearing the memory or doing a memory test. That SRAM that's on the board, that 4K of SRAM may exist just at 2000. So that starts doing stuff. And it looks like once it's done with this entire routine, it does a jump to label 1, which jumping to that seems to jump to some more subroutines, and then it goes into a loop. So this must be the main loop, because you see here at the end, it does subroutine, 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 and then it just jumps back to the main loop. So it gets stuck in this loop and just runs here forever. So this must be the loop that's probably talking on the network or interfacing with the PC and then talking on the network. We can kind of assume that this is a subroutine that sets up maybe the network interface or maybe the ISA interface. If we go to this, we can maybe make heads or tails of this. I know people looking at this and watching this video are going to know way more about this than me, but notice this is writing to a bunch of I/O ports, 2C, 2.4, 2.5, 2F, and then 40. And that's probably going to be some of these ICs. We have obviously the Western Digital Network Controller, could be initializing that. We have the clock timer controller, that's probably going to be on I/O ports. And then we have this Intel DMA controller, and these are all going to be on I/O ports. But this is obviously some type of setup because this is not in the main loop, right? This runs once, it does a bunch of writes to these particular devices, and then it returns back to this location, and now it just goes into this continual loop. Sub 1, sub 2, and then sub 5. So sub 1 seems to do stuff, jumps to another subroutine, looks like it writes to a different I/O port, 60, and then it's reading from another I/O port, another I/O port. It looks like there's a loop where it's reading a bunch of stuff from I/O ports, and it looks like that returns, and then it ends up running sub 2, which probably is doing similar things. Yeah, it seems to do computation, then it writes out, and then it writes an out, and then it sends something to this I/O port, and then it returns, and then stuff. And then we had sub 5 was in the main loop, calls from those various subroutines. And yep, it looks like this is doing a whole bunch of writes to various ports again. And one thing that's odd is if we look down in this section, this seems to just have a bunch of data. Doesn't seem to really be used. Not sure what all this stuff is used by. It's not outside of the realm of possibility that one of the two SRAM chips that are on this board is mapped into the memory space for the x86 across the ISA bus. So it could be, I mean, there's not a lot of ROM code in here, but it could be as this boots, it sets up some ROM code inside one of these SRAMs that's mapped to the PC. So Control-Alt-Delete, and it might actually execute a little tiny bit of code in one of these chips from the PC side. Someone would have to do a little bit more analysis of what this stuff is here. Is this x86 code? It's possible. We'd have to look at the routines in this ROM that are calling that and see what they're doing with this exactly. Actually, now I think about it, one way we could test that is by putting this card into a PC and then taking a look at the memory space that's in the high memory area where those chips might be mapped into, and then try to see if there's any RAM that we can read and write to. There's got to be a way for this card to communicate to the PC side, and it's just not clear to me what facilitates that. Although there's a DMA controller, and maybe it's using DMA to actually read and write directly into the memory on the PC. But that would imply you need a little bit of a program on the PC side to get this card running, and then it would be off to the races. We've got some more subroutines here. It's obviously called by all sorts of stuff, and there's just lots and lots and lots of stuff that's happening here. And then this is the end of the ROM where this is just FF. So we know that that's just nothing. And at the very beginning here, we have a few extra bytes. And then there's the copyright message that we could see when we looked at it in the hex editor. So this is a real nifty card. And it'd be really cool if we could take this thing over and maybe execute different software in the Z80 here and say use it as a co-processor card for the PC. I know it's only got 4K of RAM, so it's not a whole lot, and we don't really know how it communicates with the PC, but it's still kind of nifty that this whole thing has a dedicated 8-bit computer on it, just in an interface card, presumably a network interface card. Now, I'm not surprised I couldn't find more info on this card. I pretty much went into this video knowing that this would be, well, a big mystery in the end, but at least we have pictures of the card, a dumped ROM, and disassembly. And I know there's some smart people who are watching this who are going to be able to disassemble that code and make far more heads or tails of what's going on than I certainly could. And knowing what we have on this board when it comes to the various peripheral ICs, maybe people can make some sense of those reads and writes, those I/O port reads and writes that are happening in the ROM code. Let me go grab one of my faster booting computers and let's plug this card into that so we can poke around and see if we can try to figure out where this thing exists in memory on the PC side. Okay, I have my 386SX on the bench, and one of the things I'm concerned about is that this thing doesn't work well with high-speed buses. Probably this was designed for the IBM PC in mind. Luckily, this computer, if I turn off the auto config, allows me to set up the bus speed. So it's currently set to divided by 5, and this is a 40 megahertz system, so it's going to be running around 8 megahertz. But what I'll do is I'll swap out the crystal oscillator on this, so it's not running at 40 megahertz, and we're not booting because I need to install the XT IDE card into here. So we'll pop this in. Compact flash, yes, I'll swap out the crystal oscillator. I keep a little stash of them sitting off to the side here. And that will allow us to run the bus at a much slower speed. Okay, so I have a 32 megahertz crystal in there, which means the system should be running at 16 megahertz. And when that's divided by 5, that should be like 3 point something megahertz. So definitely within the speed limitations of any slow video card. And we should see a corresponding drop in the video card speed because of the slow bus speed. Yeah. Oh, 18 megahertz. Oh yeah, sorry, 36 megahertz crystal. Yeah, 18, which results in a bus speed around 3.6 megahertz. Okay, we're looking good. All right, so for finding things that are on the bus, first thing we can try doing is using check it. You ignore that, that's just because of Speed 600, it changes the VGA font. Now, what you can do is look at the memory map. Now, unfortunately, there's no way to really know I/O ports, like what's using an I/O port. That is just not really possible. You could try reading from them all and see if you get back just FF. I assume if you read from a real I/O port, you might actually get an actual reading of something else. But there are lots of I/O ports that are used on a motherboards for various peripherals, like the chipset and other integrated things. So it's hard to know. You have to do a lot of research to try to figure out what might be free to use by a peripheral card anyways. Okay, so up in the high memory area, we have video memory, so it's unlikely that this card would be using any of that space. High RAM, what is this? VGA compatible. Okay, so this seems to be part of the video card BIOS. Then there's nothing up in this area. And then we have high RAM, which isn't really high RAM. This is just part of the system BIOS that's on this motherboard. So later motherboards, the system BIOS started at F400, but on later systems like this, it started at F000. So it says RAM, but that's not really RAM. This is actually just ROM, as in part of the system ROM. Now, when we take a look at debug, you can see that there's that same ROM code in that same location, F000, right? But if we try to write to this, say we write 100 bytes and we're gonna write AA to that, it doesn't complain that anything happened. But if we take a look at that memory location, oh, it actually wrote to it. I think that might be happening because I have some caching turned on in the ROM BIOS. Let's just quickly turn that off. Let's disable the shadow RAM, which is what's copying the ROM code into RAM, and I guess it leaves it as writable, which seems odd to me. So let's try this again. I'm going to fill 100 bytes, that's hexadecimal, with AA. And let's see if it actually wrote to that. It still did. Okay, well, whatever. That's just a weird idiosyncrasy of this motherboard. Let's ignore that. Let's take a look at somewhere else on the board, like D0000, which happens to be the XT IDE ROM. And if we try to write to that, it shouldn't actually write to that. So let's just do that same test again. And yeah, look, there you go. Nothing actually happened. Now, if we take a look at some place in memory that has nothing, on this motherboard, it just shows up as all Fs. So if we try to write to this with 100 bytes AA, and we look at the same location again, nothing happens. Question is, if we put this card in there, will we see this RAM, for instance, mapped into any of these locations? Now, one thing I guess I have to think about is that the XT IDE ROM card in here is taking up some space, and it may be conflicting. And we'll know that pretty quickly if we put this card in here, and when I power this on, if the XT IDE no longer is recognized. Now again, if this thing were emulating a ROM, then you figure we should see something there, but we certainly didn't. Checking the memory map with check it, nothing changed. Yeah, it looks exactly the same. I'm also noticing how lame the check is in check it here. It's not even detecting the XT IDE ROM, which we know is at D000. we saw it in debug and it's not even showing up in here. Don't know why. So we can pretty much assume that if this card is mapped anywhere, that it will show up as something other than all Fs, which we know is what this motherboard does if you're trying to access memory that doesn't exist. So I'm just looking through memory to see where we have something other than just FFs. Here we go, we're in the FFs already. I think the XT IDE ROM exists from D000 all the way, I'm actually not sure what size ROM this is that's on here. I can pretty much assume that what we're looking at here is just XT IDE ROMs. So let's just try to modify that. Yeah, no change. I'm expecting that if anything is mapped into this, like from this big card, that it would show up as anything other than FF. That's why I'm not trying to write to any of this stuff. I'm just assuming that that's what we would see. It really kind of makes me feel that this thing doesn't map itself into the memory space, and that this needs software that somehow they ran on this old 5150. Well, at least it doesn't present itself as a ROM, as a boot ROM, which I would think it would do on a system that had no floppy disks. Again, I still don't fully get it. You know what's funny? I'm wondering, doesn't the 5150 have the capability of having an extra ROM on the motherboard? Like an option ROM? What if that's the case? You know what? I opened the computer and I took this card out of it, but I didn't look closely at the motherboard to see if it had a custom ROM, and that's gotta be what's happening, right? Yeah, that has to be what's going on. There is one extra ROM socket on the 5150 that's not populated normally, and I'm assuming it's some kind of an option ROM when you install that. I need to call Mike and ask him to look inside those computers and see if there's a ROM there. And if there is, maybe he can dump that, and then my XT motherboards, the one we tried earlier, should be able to populate that chip on there, or even maybe I can use my little ISA card here and populate it on there and just set it to the correct address. And maybe that's what's going on. I completely forgot about that. Okay, well, I'll be right back. All right, guess what? Luckily, Mike was working in the lab and I asked him to go take a picture of the motherboard, and this is it right here. And sure enough, there is an option ROM that was stuck into the 5150 motherboard, IBM 52086 station 36, 9600 bits per second. I'm assuming that meant, I can't believe that when I took this card out of that machine, I didn't even notice this ROM that was stuck in there. So Mike, being the rock star that he is, he dumped that ROM for me. Magix Corp, Sabarkey Enterprises, Inc., 1985. Loading, no network found from local area network, from IBM PCnet, from Eagle USART, from IBM UART, timeout, duplicate address, LAN board failed, check server, and bad interrupt. Well, obviously, if this thing does work and communicate to the card that's in this computer, it's clearly not going to be able to reach any kind of server, so that's going to generate some errors, but at least it's going to try to communicate with it. And that's it. There isn't a whole lot on this ROM. Well, I ended up sticking this onto this 28256. So yeah, I erased what's on here. Let's see what this does. Keep in mind that this ROM is not located at the stock memory location where the original ROM is, the option ROM that's on the 5150. But I don't think it should matter. It may, but it may not. Let's see what happens. It didn't even recognize it. Well, there's a few possibilities of what's going on. This may need to be located in that exact same memory location on the original 5150, which I think is F400, if I remember correctly. Let's just take a look at this again. I want to see if we can figure out how big this EPROM is. Mike said the actual physical chip was a 2732, which actually makes sense because we have 4K. Now, as for whether the checksum matches, because this needs to be a 00 for this to actually work. So if we do a checksum on this ROM, comes out to a checksum of F, which does not match this top byte. I wonder if this was a larger chip somehow than what Mike thought it was. I assume he peeled off the label to actually look at the part number. If we look at -0°, this indicates that the cassette ROM on the 5150 starts at F600 and that implies that U28 is just below that. And it says U28 is absolutely searched while the system is looking for boot ROMs that are available. Basically, they're looking for that signature check, which is that checksum, that last byte. So my assumption is it's F500 where that chip is actually located, and I assume it can handle a 4K ROM chip. Mike lives over 2 hours away from me, so I can't go look at this computer myself. So I just sent a message to him asking if he peeled the label off on that chip just to verify that it was a 2732, because maybe we have a truncated dump. Oh, you know what? It says right there that this is actually a Motorola 68764C, which actually means that's an 8K EPROM. And I don't think he'll be able to dump that unless he has something like the Retro Chip Tester Pro, because normal things like the TL866 cannot dump that type of chip. All right, I just got off the phone with Mike, and he has Retro Chip Tester Pro, luckily, because the 6845 is definitely not something you can just read in anything. And here is the file. Okay, so it looks the same. Let's see if it's got the checksum byte at the end. Well, I don't know. They might have manipulated the contents so that the checksum is actually FF. Let's give that a try. Checksum is 00, which I think is correct. I think I was misspoken before. I'm gonna write this into the EPROM and let's see if this works. ROM card is in the machine, powered up, see what happens. Fingers crossed. Oh, look, LAN board failed. Interesting. Well, at least we have a working ROM, but not cool that the LAN board says failed. And we know this is not a bus speed problem, because remember, this is running at 3.6 megahertz and the computer is really slow. Although I suppose to really be thorough, I should test this on a real XT. So we're not dealing with a fast CPU, because it could be the routines that talk to the card are just running too quickly. Oh, it rebooted itself. That's interesting. Okay, so I just grabbed this XT motherboard. This is one that I've done some previous repairs on in the past, which I think the only thing that was wrong with this motherboard was simply that this power supply had some bad caps in it, and that was keeping this thing from working reliably. Oh, I'm gonna use a block of wood to prop the motherboard up onto. Sure, why not? And we're gonna run this with MDA or CGA, so it's exactly like the original system. I think the only thing that's not gonna be like the original system is that I'm gonna be using a ROM at a different location with this little card. Okay, we are looking at the RGB to HDMI, which is currently set to Hercules. Let's see. Okay, this computer is configured, must be configured for CGA. So we just flip that switch there. Now it should be coming up in MDA mode. Oh, yeah. All right, well, boring, because it's obviously not gonna work, but that tells us that obviously this card or the ROM doesn't work on faster systems. And there it is, version 2.2 loading from local area network address 54, which is interesting because I was pretty sure, didn't it say station 36? Yeah, it said station 36. I was just looking at the photo there. All right, so I think that's all there really is to discover about this. I will, of course, share the photos, the ROM dump from this card, plus the ROM dump from the motherboard up on archive.org, so anyone can take a look at that. Huge thank you to Mike for getting this card to me, and of course, dumping the ROM, especially on the fly like I needed him to do today. And check out his channel if you haven't already. I'll put a link in the description below. He mainly focuses on Commodore stuff, and the funny thing is, when I was over at his house recently, he was trying to give me these 5150s, but they were super rusty, and I was like, oh no, I already got 5150s and I don't need them. So I took this card and I thought this will be interesting to make a video about, but I didn't take the computers. But I told him if no one takes those computers off his hands, then I will probably end up with the motherboards, because at least we can do a troubleshooting and repair if those motherboards aren't working. The computers were in super sad shape, tons of rust on the inside. They were stored in a pretty terrible environment. So yeah, very interesting to look at this Z80 powered network card from Destek. If anyone watching wants to try to disassemble the code that was on this ROM, and maybe we could reprogram this to do some more fun stuff, let me know. Obviously, now that we have the PC ROM that works, that communicates with this, we can figure out how this communicates to the PC, which I'm assuming is going to be I/O ports. And the interesting thing is that ROM just worked. It communicated to this card. So however these jumpers or switches are set up on here is clearly functional for that communication to happen. Although, as we saw, it needs to have a slow computer, an IBM PCXT, for this to actually work. And I'm thinking that might actually be a CPU speed issue more than bus speed. The 386SX, that motherboard has cache as well, so it really runs a lot faster. So any routines that it's using for timing, like if it's just using loops and NOPs and things like that for timing, aren't going to work obviously on the 386SX and probably require a 4.77 megahertz PC to actually function. If you happen to know more about this Destek networking stuff that this thing seems to do, let me know. We saw a little bit about it on archive.org, but clearly there's no photos of this, no dumps of this, no documentation, no nothing. So very curious, and that's been a fun little journey, I have to say. Probably just gonna toss this into my box of random unknown cards, and maybe someone out there one day will discover more parts of this and we can create a Des network. I don't even know what this plugs into, but there's a switch or something, I don't even know. Pretty cool. So that's going to be it for this video. Hope you enjoyed this little exploration, and if you did, thumbs up. If you didn't, you know what to do. Huge thanks to my supporters. Names are up the side of the screen to make it possible to do this full time. And you can become a supporter at the links in the description below, and thumbs up, subscribe, all the usual YouTube stuff. And that is going to be that. So stay healthy, stay safe, and I'll see you next time. Bye.